about the workshop. But okay, cool. So the next thing we're talking about kind of dovetails pretty nicely with loops. Is coercion and truthiness. And those are kind of words that maybe you don't use very often, like just colloquially. But you can also translate to coercion means changing data types, and truthiness means is it true or not. That's pretty much it. So when we talk about coercion, the main thing we want to talk when we talk about coercion, the main thing is to think about okay, how do we change something from one data type to another data type in JavaScript? And it's something that we actually do quite often. Um, the easier way to understand coercion is through something called explicit coercion. As the name indicates, explicit coercion means we're just being very, very direct, very, very open, very, very transparent about what we're changing something to, like what's the end result. So here I have something called num, which is a number 10. If I do type of num, I'm going to get back a number. However, if I ever want to change that num into a string type, as in I want to change it from a number 10 into a string with two characters, the first character being 1 and the second character being 0, all I have to do is pass it into the actual type itself, right? Notice how string here, the first letter is capitalized. Remember from earlier, I said, what does it mean when we have a variable whose first letter is capitalized? It means it's a class, right? So in this case, we won't get too much into classes, but just know that every data type that we've seen so far, booleans, numbers, arrays, objects, those are all classes in JavaScript, and they're all pre-built into JavaScript for you. So whenever you do anything in JavaScript, you already have access to the string class, to the array class, to the boolean class, etc. Here, all we're doing is we're calling the string class, or we're passing it in a value. And what JavaScript's going to do is JavaScript's going to say, okay, great, whatever you gave me, I'm going to try to turn it into a string, if I can. Okay, and so in this case, it's called explicit coercion because we're taking something num, and we're like, there's no ambiguity about what we're doing here, right? Like we're feeding it into the string class, which means we expect to get a string back. And that's pretty much all there is to explicit coercion. It just means, once again, we're taking a class and we're saying, hey, whatever I give you, turn it into this data type. Because once again, coercion is all about changing data from one type to another type. Similarly, if I want to change a string with 4 characters of 1, 0, 0, 0, and I want to make it into a number, well, lo and behold, JavaScript has a pre-built-in number class. Notice how the n in number is uppercase, right? Indicating that this is a class, and just take it for granted, it comes built in with JavaScript. So whatever I pass in to this number class, JavaScript's going to say, all right, you want a number back, so I'm going to do my best to turn this string into a number for you. And so when I run this, once again, I get back a number. Once again, realize, explicit coercion, right? Explicit means we clearly define what class, or rather, what class we want to get back, what type of data we want to get back. There's no ambiguity about what our outcome's going to be. And that's pretty much it for explicit coercion, right? We're just being very, very clear, direct about what we want to get back. Implicit coercion is kind of where things get a little bit more tricky, and we want to be a little more careful. Implicit coercion is the same in that we also are changing data types, but with implicit coercion, we're being a little bit more subtle. We're being a little bit less transparent about what we're doing behind the scenes. So let's take something like this, right? If I say, hey, add 10 and 20 for me, well, I think everyone knows I get 30. There's not much ambiguity there. But if I say, hey, let's add 2 strings together, what happens when we add 2 strings together? Well, we just kind of shove them together, right? So this becomes not 30, it becomes a string with 4 letters, right? 1, 0, 2, 0. It's a string with 4 letters, right? It's the same way we just shove 2 words together. And that still makes sense. But then what if I try to do something like that, where I try to add a number to a string? What do I get as the outcome? This is an example of explicit coercion, because guess what? If I'm adding a number to a string, I'm going to get back a data type that has to be different from at least one of those 2 things, right? If it's a number, it's going to be different than a string. If it's a string, it's different than a number. But it can't be the same as both of the things that went into it, right? And so we call it implicit coercion is because we're changing that data type. We're changing not short into a data type, but we're not we're not telling you exactly what we're changing it into, right? That's where the implicitness comes in. We're being a lot more opaque about what's happening behind the scenes. In this case, and this is unfortunately something that you just kind of need to memorize or know, when we add in a number to a string, what JavaScript's going to do is JavaScript's going to convert both things into a string first. It's going to convert the string to a string, or rather it maintains it as a string, and it's going to convert the number into a string, and then it will do the plus operation. Except at that point, the plus operation is no longer the mathematical plus operation, it's the string plus operation, right? And remember, for a string plus operation, we're basically just shoving those two words really together, right? So when we do 10 plus 20, the implicit coercion happens is we're implicitly converting this 10 to what?
String.
We're converting it into a string with two letters, 1 and 0, and then we're doing like this plus operation, which is the same as this plus operation, which means we get 10 or 1020. Okay? Once again, we're chaining data types, but it's implicit because at no point did I ever say, hey, by the way, convert everything into a string. It just kind of happens. And so implicit coercion is not just subtle, it's also very tricky and potentially dangerous, right? Because if someone looks at that and they're not careful, they might not know what they're getting back. And if they try to use that string-like number, or vice versa, it's going to have probably unintended side effects. So the plus sign is one example of us using implicit coercion. Okay. Similarly, if we talk about implicit coercion, another way to think about it, and this is something I really like, is it also touches on a deeper issue fundamental to JavaScript, right? When computers execute code, remember, computers are not good with ambiguity. Computers don't just like, well, it kind of feels right, so I'll just do it this way, right? Like, computer never says that. Computer says, I have very explicit, binary commands to do this, then this, then this, then this. So when I look at this code here, how a computer's going to read this code is it's going to say, okay, one, let me try to figure out what everything to the right-hand side of the equal sign is, right? So I'm only looking at this side. But when I look at this side, I'm not looking at everything holistically, right? I'm looking at it one piece at a time. How does a computer read code? It reads it from left to right, right? So the way a computer reads that is that it's going to say, okay, what's this string 10 plus 20? Well, and we'll cover all of this later on, right? Like, this part doesn't matter just yet. The computer reads it from left to right, so it needs to do things one at a time. How do I add the string 10 to a number 20? Well, on the last slide, we just said, right, we convert everything to a string first, and then we do the concat or the string plus operation. So this becomes what? A string of 1020. After we're at that point, then we add in the 30. Well, how do we add in a string plus a number? Well, we just did it, right? We convert everything to a number, and then we add it as a string, and so on and so forth. And so after we're done with this process, what we get is that 1020304050, right? It's a massive string because, once again, if we read this from left to right sequentially, in order, a computer treats it as a string, and then makes this into a string, and it makes this into a string, and it makes this into a string, and it makes this into a string. So the string only gets bigger, right? Once again, it's implicit because nowhere in that function am I ever invoking the string class, but the plus sign is actually just doing it for me behind the scenes. Now, that's different from this example here, right? How is this different? Well, if I'm a computer and I read this, right, the first part of it is still similar in the sense that I'm saying, okay, there's an equal sign, right? So let me figure out what's to the right-hand side of the equal sign first, all of this. And now let me tackle this one at a time, right? What's 10 plus 20? 30, right? I'm adding two numbers. There's no confusion here, right? So what's 30 plus 30? 60 plus 40? 100. And what's 100 plus the string 50? 10050. And so when you're looking at things, right, like be careful. Like, the best way I can say this is think like a computer would, right? Like, when you look at your code, don't just like gloss over details that you don't quite understand, because a computer doesn't have the luxury, right? A computer is very, very precise about what it's doing. There's no ambiguity with a computer. So when a computer reads that code, if I put myself in the computer's shoes, I'm going to read that code, 10 plus 20, two numbers, 30 plus 30, two numbers, plus 40, two numbers, and then I'm going to get to the very end, right? So once again, we're doing implicit coercion here as well, because ultimately we get back a string, but the process through which we got to that string is different depending on the order in which we do things, okay? So this is pretty much all we're going to talk about with the plus sign and implicit coercion. And for the most part, we're only going to deal with strings plus numbers. So you don't need to worry too much at this point about the other data types. Yeah, Patricia? as long as those two things it doesn't matter whether a number comes first or a string comes first. As long as it's number plus a string or a string plus a number, it will convert both things to a number. I'll do it. Yeah.
I guess just to put this in context, you're almost always trying to avoid this happening, right?
Yes, and explicit coercion is usually always better. It's usually always safer. For these kind of problems, possibly, but like we'll see some other examples in which it actually works in our favor. Yeah. So sometimes. All right. Okay. So God, shoot. I want to say serial, but I know that's not right. Siori. All right. Yeah. So you asked earlier about like the difference between double equal signs and triple equal signs, right? So we're going to talk about that today. Okay. So triple equal signs, or rather, let's talk about why we don't want to use double equal signs. So these are, I mean, you can kind of read it, right? Like when we use double equal signs, we get some pretty wonky answers. Sometimes the answers make sense, sometimes they don't, which once again, terrible for computers, right? Like we want things to make sense all the time. And the reason why we don't want to, why we typically advertise or advise people not to use, why we advise people not to use double equal signs is because what does triple equal sign mean? Triple equal sign means when you're comparing two things, those two things are of the same type and they also have the same value. Okay, so triple equal sign means same type plus same value. Double equal sign means, hey, let me try changing them to the same type first and then comparing them, right? It may sound good in practice, but in actuality, like that changing two different things to the same type, it actually is a lot more messy than you think it is, than you might think it is. So let's talk about, let's see, MDN double equal comparison. Okay, see if this gives us. All right. Yeah, this guy. Okay. So when we use double equal signs, this is actually the table that kind of goes, that JavaScript runs in the background to figure out are these two things equal, right? So if I'm comparing a number to a number, oh, it's just a really straightforward triple equal sign, right? There's no confusion there. If I'm comparing a number to a string, well, it means the number stays a number. I try to convert the string to a number, and then I compare them, which also kind of makes sense. But then when we look at some of these other things, like if I compare an object to a Boolean, like I do this operation. I change the Boolean to a number, I change the object to a primitive, right? So what does that mean? I'm not quite sure either, right? But what you'll notice is that like this table is not very, like it's symmetrical, but it's also not very symmetrical, right? There are a lot of things here that like a person just wouldn't be able to kind of keep track of correctly in their heads. And so unless you feel very confident navigating this table, like this is why we almost strongly advocate people to never ever use double equal signs. Because when you use double equal signs, this is what you're potentially setting yourself up for, right? A lot of comparisons that do have rules. They're not just pulling rules out of the wild. They do have rules, but the rules are very convoluted, right? And so in almost every case, it's almost better to use triple equal signs, even if you have to do an explicit coercion on your part first, right? So if I want to compare a string to a number, and I think, well, double equal signs can work, what we rather want you to do is convert that string to a number, or convert the number to a string first explicitly, and then use a triple equal sign. Okay. So in short, this is the reason why we don't really want people to use double equal signs, is because there's a lot more going on behind the scenes that someone realizes, and a triple equal sign is just a lot more precise, right? If I tell you something is the same type and has the same value, there's no ambiguity, right? You're like, okay, great, they're the same thing. I can move on now. If I say they're double equals, you don't actually know if like, great, so were they equal before the conversion, or are they just loosely equal, right? Or rather, are they the same type, or are they equal before the conversion or after the conversion, right? So there's just more questions, and so because of that, we really tell people not to use triple equal signs.
Just to clarify.
Or sorry, double equal signs. Yeah.
When comparing two different types with triple equals, forget about double equals. Is it going to throw an error?
No, it'll tell you they're not equal.
Is that an error? Just saying
No.
that's not equal.
It'll say false.
False, okay.
Yeah, because if the premise of triple equals that they have to be the same type and same value,
Yeah.
if the first condition is met, then it'll say great, they're not equal, and you move on. Yeah. So yeah, triple equal signs with any two different data types are inherently not equal. Great. So the other kind of coercion we'll talk a lot about is Boolean coercion, or rather this idea of truthiness. So everything in JavaScript and really most CS boils down to this idea of booleans, right? It's either 1 or 0, so it's true or it's false. And rather than telling you like a lot of things, or rather, let's go this. So when I say truthy, it just means if I take a value and try to coerce into a boolean, it's going to give me true. And falsy values are values that if I coerce into a boolean, it gives me false. Okay, that's roughly what the high-level definitions are. Most values are truthy, and actually, in terms of understanding what's truthy and what's falsy, it's a lot easier to understand what's falsy, right? So I'm just gonna skip a lot of. Okay, great. So these are the only kind of falsy values you'll see in JavaScript, right? So for a string, the only false string is an empty string. For a number, the only two false numbers are either 0 or something called not a number, NaN, on the very bottom there. And where that comes from is if I try to convert like my name into a number, it will say, hey, I can't do it. This is not a number, right? So these are the only two false numbers. Null is always false, and undefined is always false, and obviously false is always false. Everything else in JavaScript, if I convert it to a boolean, will be true. Okay. So yeah. So a lot of times you'll see us kind of use falsy and truthy in this way. Okay. So why is converting something to a boolean important? Or rather, what's an example that we've seen today where converting things into a boolean was super critical? Loops, right? The conditionals. Notice how earlier I said, like usually like the conditional is an expression, right? That once we evaluate it, it's either going to give us true or false. But in actuality, like JavaScript extends that further. JavaScript doesn't even care if it's an expression or not. Whatever is in that conditional, even if it doesn't give you true or false, it will try converting it into a boolean, and it'll either be true or false, right? So what the conditional really does is the conditional is doing a boolean coercion, right? It's coercing whatever you have in there into true or into false. And once again, it has to, right? Because as a conditional, it has to know, do I keep running or not? I can't deal with ambiguity. I either run or I don't, right? So therefore, so in the pre-example, right, is 5 greater than 0? Okay, that's a mathematical expression. I get back into true or false. I can live with that. But I can even do something like this. If apples, console log out if, else console log out else, right? Apples is a string. Is it a true string or a false string?
True.
It's a true string, right? Because the only false string is an empty string, and it's clearly not an empty string. So therefore, that's true, right? And this is perfectly valid JavaScript, right? Because basically what JavaScript's going to do, or rather what this conditional is going to do is it's going to say, whatever you have in here, I'm going to evaluate you first, and whatever I get back, I'm then going to convert it into a boolean. I'm going to coerce into a boolean. If I coerce the string apples into a boolean, I get back true, right? So this is how whenever you write an if statement or a while statement, it will always do something, right? There's never a scenario in which it will say, oh, like, I don't know how to handle this, let me just quit, right? It will always do something. It will always evaluate true or always evaluate false for this reason alone. It's because when you convert something into a boolean, you will always get back a true or a false. You may not get back what you expected to, but you will always get back one of those two values. So similarly, if I have this, it's going to console log out yes all the time. Or if I have if 0, I'm going to console log out back no all the time. Same idea. Any questions so far before we go to the last two things? Okay. The exclamation mark is something that you might see in JavaScript quite a bit. It's called the bang operator, B-A-N-G. And what it does is it basically takes the opposite of whatever your value currently is. So if I have a number and I put a bang in front of it, it will basically, the way to think about it is like, is my number true or false? And if you say true, then this will give you back false. Similarly, if this is false, it will give you back true, right? It basically says, what is the opposite Boolean value of whatever it is you put in front of it? Because it gives you the opposite, you also might hear people call it the not operator. In fact, in Python, I think it's called not, right? So if not this, then you'll get the back this.
The not operator?
In other languages, it's called the not operator. You might see people use it because basically, because it gives you the opposite of whatever it is you're looking at. It can also just be the opposite of that. So, bang true is going to give you false because true is true. Bang any string that's not empty is going to give you back false because the string itself is truthy, right? So the opposite of that must be falsy. And so we go through all these things. Basically, bang in front of anything truthy gives you a false, and then bang in front of anything falsy gives you true. The other thing that just to kind of is like more of a shorthand than anything else, you might also see 2 exclamation marks or 2 bangs in a row or a double bang. So you read line 4 is like double bang true, double bang ABC, and what that does is it's basically a shorthand to convert whatever it is you have into a Boolean value, right? Because if ABC is true, bang ABC is gonna give you back what? False. And so what's bang of false? True, right? So basically, the double exclamation mark is a way to use implicit coercion to convert whatever you have now into its Boolean form, which is either going to be true or it's false, right? And so because of that, you might see a bang operator too. If someone wants to kind of be lazy and just convert something into a Boolean, this is a very common way to do it as well. So earlier, so for one of the problems that you all did, I think it was like you're trying to add every odd number or like every odd number between one and the number, right? And I think what almost all the groups did was they did something where it's like, oh, like let me find the remainder when divided by 2, and if it's 0, then I do this, or if it's 1, I do this, right? Well, rather than comparing it to 0, we can also just do exclamation mark that value, right? Because if it's 0, then you handle it one way, and if it's 1, then you handle it the other way. So, like, as you start doing more and more of these problems, you pick up more and more of these shorthand ways to do things. But, like, these are applicable, and you will see this, like, in the wild, right? People do use bang operators quite a bit. Okay, the last 2 things to talk about are what we call logical operators. Logical operators are something that, like, I think makes sense if you think about it in English terms more than anything else. The 2 logical operators that we're talking about are and or. Okay, and or. The way that and works is if I say like let me go to the grocery store, let me buy milk and eggs and bread and like cereal, right? It means like at every successive stage I need to meet all of those criteria, right? If I get just eggs, then my shopping trip was a failure because I didn't get 3 out of the 4 things that I needed, right? So what and does in JavaScript is and basically takes whatever it is, like whatever things are before and after it, and it will do a check. It will convert it into a Boolean, and then it will do a sequential check for you. So what does that mean? If I do 10 and 20, what it'll do is it will convert the 10 to a Boolean first and say, is it true or not? If it's true, it will convert the second thing to a Boolean and say, is this true or not? If this is true, it will give back this truthy value. If this was false, or if this was false, it will give you back false. Right? So if I have something like, so we're going to do a few more examples, right? So if I have something like line 3, right? If 10 and 0, well, the first thing we'll do is we'll convert 10 to a Boolean, right? And that's going to give us true. So we move on to the next thing. Let's convert 0 to a Boolean. Well, that's false. So this AND operator is going to give us back what? False. So then, because of that, this if statement doesn't run, but the else will. And so therefore we get 0 is falsy.
What's the difference between that one and the one that's said true, other than the else? Like, it said 10 and 20. Now it's saying 10 and 0. If the else statement wasn't there, would it still be true?
The else has no bearing on whether or not something's true or false. The else is just saying, like, if true, do this. Else, do this. If you don't have the else, they're just saying, do nothing.
Okay, so what's the difference between this and 10 and 0?
Because 20 is truthy and 0 is falsy.
Not sure if I'm following that, but you can go.
Well, this is like super critical to understanding and, right? This is the and operator, right? The previous slide was 10 and 0. So we try to check if both things are truthy or not. And the answer is no, one of them is falsy. So the answer is false. And here we're trying to check if 10 and 20 are both truthy. and they are both truthy.
How do you define how do you know 0 isn't truthy?
It's just a condition.
0 is just false.
Yep.
Yeah. 1 and 0.
Okay,
Null,
got it.
fine.
This guy here, remember?
Yep.
0 is one of the few falsy things, so therefore it's going to give us falsy.
Thanks.
Yep. Cool. So one of the cool things about logical operators is that computers are designed, to also be as efficient as possible. So because and is something that's like, it's like, hey, like every criteria has to be met. What it'll also do is if it finds that if in a list of things, if a criteria isn't met, it'll just say, great, let's stop this. Like for example, if I say I need, milk and eggs and cereal, and this sorts out of milk, I don't even need to check eggs and cereal anymore, right? I can tell you I'm not going to complete my shopping trip, right? This sort doesn't have what I need. And so logical operators have operate in a very similar way as well. So and will either return the first falsy value, or it will return the last value if everything is truthy, right? So if I look at this example here on line 4, return value is a chain of these 3 things, right? Let's say 10 and apples and 0 and null. Well, 10 is truthy, so we're going to keep moving. Apples is truthy, we're going to keep moving. 0 is not truthy, so when I look at what this returns, I'm actually going to return 0 right away, right? And the thing here is we never check null, and we don't need to, right? Because if this thing is false, it doesn't matter what this is anymore. And so we don't need to expend the extra energy to figure out what the rest of the list is. As soon as we hit the first false, we can say our job's over, this is not what we need, right? Similarly, down here, if I have a chain of things that are all truthy, which is lucky plus number and 7, well, I'm going to give you back a 7. And so if I use an AND operator and I look at my outcome, if my thing is truthy, then I know for a fact everything in that list was truthy. If my thing was falsy, then it means at least one of the things was falsy, and I don't even need to check the rest of the list anymore. So just as a way for like when you use an AND operator, like it doesn't like if you get a false value, it doesn't mean that like there was only one false value. It means there was at least one false value, and that's all the computer cares about, right? If you cared about, however, I guess the corollary to AND would be OR, right? Which is, hey, I just need to know, was anything in here true, right? Like I just need one match, right? It's like you're, applying for like 5 jobs and you feel indifferent about all of them, right? It's like I just need one job, right? Getting 4 jobs would be nice, but I just need one job. And so with the OR operator, OR is like 2 pipe symbols, like 2 straight lines on your keyboard is usually right beneath the delete button. What the OR operator does is it will say, is anything in this list true? And kind of like the way that AND stops once it finds a false, OR stops once it finds a true, right? Because if your question is anything true, as soon as you find one true value, you say, great, like it's true, like I found it, I can keep moving now. And so here for return value 1, when we have a chain of these things, right, it will say, no, is that true or false? Well, it's false. Let's keep moving. Undefined, is that true or false? It's false. Happy, is that true or false? It's true. Oh, great. I'm done. Let's just return happy, right? I found my first true value. Pumpkin is also true, but it doesn't matter because for the purposes of an OR statement, I just want to know, is there at least one truthy thing? And if so, what is it? And in fact, it's here. Similarly, if everything here is false, so false, null, this is a false equation and not a number. If everything is false, then what I'll do is I'll return back the last value, right? And so once again, if I use an OR statement and I get back a truthy value, then all I need to know is that like, hey, there was at least one truthy thing, and it was this. If I get like a falsy value, then I can pretty much rest assured everything else in that list that you gave me was also false or falsy. All right, that was it. Any questions? Yeah.
It's a little topic, but how does coercion relate to the idea of casting?
Coercion and casting are very much the same thing.
Oh, they're the same thing.
Casting, I think, is probably used more for explicit coercion when you're explicitly changing a type from one to the other. But they're fairly synonymous in most cases.
Okay.
Yeah.
So in a for loop, if there's multiple end statements linked together, the for
Multiple in statements.
in a for loop, if there are multiple statements linked by an end operator,
Okay.
it will just know to roll it all up into either true or false. But outside of a for loop, it does what you just described.
Sorry, not following. You said multiple statements in a.
Yeah. So if you did a for loop, or sorry,
Okay. Sorry. So we'll
you,
all right. What am I typing here?
uh,
For loop.
Sorry, if you do an if statement.
Okay.
If you do if, then you have two statements that are linked by an and operator. You say if true and
Oh, and operator. Sorry.
and operator, yeah.
Gotcha.
True and false.
Like this.
Yep. It wouldn't work the way that you're describing it because an if statement rolls it all up into just one.
Right. So basically, like, as you're saying, okay. So basically, think about it this way: if I did this, if I didn't have this if statement here, and I did this, I would get back what? Oh, sorry, this is a typo. I would get back false, right? Rather, let's change this into like not a number. Okay. If I did use this in context of an if statement, the difference between these two statements is when I do this in an if statement here, what I'm really doing is I'm actually really doing something like this. I take whatever I get and I convert it into a Boolean, right? And so if I use an if statement, I'm going to get back false, right? So even though like the technical definition, the technical result of this AND operation is not a number, whenever I use a conditional, it's either going to be true or false, right? And so this will appear to be false, even though the actual value is like whatever it's supposed to be.
No, I'm a little confused to be honest.
Yep.
So in the Boolean, you get false because they all have to be true. You're saying it's going to behave differently below where it's not in a condition?
Yeah. So okay. So let's say console.log. Let's say this is like the raw value, right? Ugh. Great. Okay. So raw value is not a number, right? Actually, let's just do. Okay, let raw value equal that. If I do raw value here, I get back this, right? In a conditional. Oh man, I cannot type. In a conditional value, I basically am looking at this.
Okay.
So when I run this now, the raw value is not a number. The conditional value is false. Right. And so, like the way that the Boolean, the way the conditionals works is that like, yes, we're converting to a Boolean, but you can almost think of it as it's converting to a Boolean, but really it's just like if it's false, it's going to be false, right? Or it's falsely, it's going to be false.
Right.
So like so like in conditionals, we almost like never use this raw value directly anyway, so you don't even see it. But yeah, in a conditional value, like it is using that raw value still. It's just it converts it and processes it before you even get to like use it or look at it directly. Okay. Any other questions?
You
Scott?
chain different logical operators together, do they have the same precedence?
Precedence?
Like, or like, without parentheses, like what would happen if you had multiple ors and ands in that statement?
Okay, so let's read this way. So the only precedent I'm aware of without parentheses is just it reads it from left to right, right? So between 4 and 4 is either one of these truthy, and the answer is yes. The first truth is going to be 4, and then between 4 and Oh wait, no, you're right. Between 4 and 4, it will just return back the first the first truthy value, and so this is going to give you back a 4.
But it'll handle them separately. Like it'll do the or and then it'll go to the right and do the and.
Yeah, let me think real quick. So 4 and actually, let's do this. So if I do logical operator, JavaScript precedent priority. All right. All right, let's take a look at some things here. Oh, maybe and takes precedence from left to right. Let me see. Or okay, I guess I was wrong. I guess and takes precedence over or. Did not know that. It looks like and is precedence over or. This is a ternary, which makes sense. And then I don't know what this is. Oh, this is like the shorthand. Okay, yeah, so I guess it would go through left to right. It would read all the ands first. It would convert the ands, and then it would go through it and then read the ors. So, I'm sorry? Yeah, like, yeah, so, yeah, this is a good point. So, like, with any of these things, like, it's like, even if a computer does a certain way, like, just to make it easier for humans to read, just, like, do it like normally, like, do it with parentheses, like, group the things you want to check together with parentheses to make that easier, right? So, in this case, like, even, like, so the priority level in this case should be something like this. I would almost say just do that anyway. So that when someone looks at it, like, okay, I want to group these two things together and then check it against the or. So yeah, even though JavaScript might do it a certain way, just like for human readability, it might just be easier to group them together. Yep. Yeah, I think yeah, like it is one of those things like in the wild, like I think people just take that into account. So like I almost never see like and or ors kind of chain together on the same level, unless like there's a very specific reason. But in most cases, people just do something like this. But yeah, I guess I learned today that and takes precedence over ors. Huh, interesting. Cool. Right. Any other questions? Good? All right, cool. Yeah, cool.